Hi guys, this is homework 15's solutions video. So after reading our assigned reading of our textbook, please try the homework PDF problems and please look through this if you think this will be any help. All right, so let's start with the first problem. So this week we are extending our knowledge of what we covered. I think we mostly covered the most important parts through the first order and the second order differential equations. The extension, which is higher order of the differential equations, is pretty much, it follows the same logic and concepts that we have covered so far. So let's try the first assigned problem. All right, so this is the given, and we're even given the boundary problems, boundary values. So if you remember what we did for the first order differential equation, we actually took this with using the r. So we're going to do the same thing actually. So we're going to write it as r cubed plus 5r squared minus 22r plus 56 equals to 0. All right, so the next step would be for us to factor this. You can use any factoring methods you like. You can even graph this using your graphing calculator, but if you do, you will get to r plus 4, r minus 2, and r minus 7. All right, so this tells us that we have 3 real solutions, and they're going to be -4, 2, and 7. And so we can go ahead and write our general solution. That's going to be C1 e to the power of -4t plus C2 e to the power of positive 2t and C3 e to the power of positive 7t. So we would stop here if our boundaries were not given, but since they're given, we would have to go a little further to solve for the C1, C2, and C3s. Okay, so to set up for solving them, I'm just going to go ahead and take the differential of the general solution that we found. So differentiated once, that would be -4 C1 e to the power of -4t plus 2c2 and plus 7 c3. And I think we need to do this one more time. So that's going to be 16c1 plus 4c2 and 49. Okay, so given these, we're now going to have to plug in zeros to solve for the constants. So let's do that. So I'll plug in 0 to our original equation. That will give us C1 plus C2 plus C3, and this should equal to 1. Plugging in 0 to the first order, that's going to give us -4 C1 plus 2 C2 plus 7 C3. This will equal to -2. And also plugging into the third equation, we would get positive 16 C1 plus 4 C2 plus 49 C3, and this should equal to -4. All right, so we have 3 unknowns and 3 equations, so all of those variables are solvable. Again, you guys can take any methods of solving. You guys can maybe use elimination. Probably the easiest method is using the matrix. You guys can use the augmented matrix or just utilize the matrix function that you have on your calculator. So in other words, I could rewrite this as 1, 1, 1, -4, 2, 7, 16, 4, 49, and C1, C2, C3. This should equal to 1, -2, -4. So you can use the calculator function has the R ref. You can use this just to find, I think it's the quickest way of finding C1, C2, and C3, or you guys can use the inverse matrix to solve. There are many other methods. And if you do, you should get the solution of C1, 14 over 33, C2 would be 13 over 15, and C3 would be negative 16 over 55. All right, so I guess you guys can plug this back into this general equation, and that would be the solution for number 1. All right, let's go ahead and do number 2. So this one, as you see, is not, the boundaries are not given, so we're just going to find the general equation. Let's take the method that the same thing that we did for the first order differential equation. Let's do that again. So 2r to the 4th power plus 11, r cubed plus 18, r squared plus 4r minus 8 equals to 0. Now it's not very intuitive what the factors of this would be, but probably I would graph this and see where the zeros are. So I kind of did quickly graph this, and the graph looks something like this, and just need to find where they cross the x-axis, and they happen to be negative 2 and 1/2. So the graph looks like this. So by fully factoring out, I divided by r plus 2 by this equation. And then after I kept dividing by also 2r minus 1, because this is 1/2 and this was negative 2. If you factor this out, you'll get 2r minus 1, r plus 2 cubed. All right, it makes sense because there are 3 r's and just 1, which adds up to the total, the highest order of 4. All right, so this tells us that we have 2 solutions. R can be 1/2 or negative 2. It's really important that this negative 2 has the multiplicity of 3 because it's repeated 3 times. This has a multiplicity, 1/2 has a multiplicity of 1. Okay, so now linking back to our concepts back in the second order differential equations, what we have to do is this y of t would be, well, let's figure out this part. That's a pretty easy part. That's a whole number. So we can just easily write as c1 e to the power of 1/2 t. So now the problem is this part. This part has been repeated 3 times, and just linking back to our the previous 2 homework sets that we did, if we had something like this, r cubed plus something, let's do 2r squared plus r minus 8. If we had something like this, then kind of link back to finding the particular solution of this type of order. So what this will be is we would write c2 e to the power of negative 2t, and we kind of have to repeat this 2 more times because, again, this has a multiplicity of 3. The next time we repeat, it's going to have a variable of t multiplied, e to the power of negative 2t, and the last time it repeats, it's going to have t squared, e to the power of negative 2t. So there you go. This is the answer to problem number 2. If we had multiplicity of 5 instead of 3, then we would keep going where we would have to add 2 more terms. So it would be c4 t cubed e to the power of negative 2t, and 1 more c5 t to the 4th e to the power of negative 2t. All right, so let's now take a look at the case where it's no longer just a whole nice numbers. What if we had the solutions ending up in irrational numbers? So we just covered this was just a whole number, and this was the repeated solution. And now let's take a look at this one. All right, so I'm going to rewrite this again using the r explicitly for y. R to the fourth plus 104 r cubed plus 408 r squared plus 156 r equals to 0. So immediately I can factor out r because all the terms have r's in it, and afterwards be r to the fourth plus 12r to the cube and so on. I can further factor this out, and actually I would get r squared plus 6r plus 34 to the squared equals to 0. So yeah, so the factoring part is mostly of a high school math, and this is the result that we got after factoring. The easiest solution is coming from this. R has to be 0. From this part, we're just going to forget that this has a multiplicity of 2. Okay, let's forget about that for now. If you factor this, you will get an irrational number. And I got these solutions by using the quadratic formula. And they were -3 plus minus 5i. All right, so let's make a note. This one, 0, has a multiplicity of 1. And this answer, this has multiplicity of 2. And it's important to note that -3 plus 5i has multiplicity of 2, as well as -3 minus 5i has a multiplicity of 2. So we have 5 solutions going on here. There are 4 terms that will be stemming out from this, and just 1 term stemming out from 0. Okay, so let's write the general formula for the solution. So y of t is going to be c1 e to the power of 0t, or e to the power of 0 is just 1, so I can just kind of just get rid of this. So c1 times 1 is just going to be c1. Okay, now let's take a look at this part. What we did before, we started out with the original, this is the original, and we kept adding t and t squared. We're going to do the same thing here. If you remember from the second order differential equations, if we have irrational numbers as irrational solutions, then that's gonna take on the form utilizing the cosine and sine. So remember, if it was alpha plus minus beta I, then it was going to be c1 e to the alpha t cosine of beta t plus c2 e to the alpha t sine of beta t. So we're going to take on that form, and this will be plus c2 e to the power of -3t cosine of 5t plus c3 e to the power of -3t sine of 5t. Now what we have to do is we're going to have to repeat these two, the same thing, but add additional t variable to it, times t cosine 5t plus c3 e to the power of -3t t sine of 5t, just to satisfy the fact that this one has the multiplicity of 2. Again, if this had a multiplicity of 3, which would mean that if this was 3 instead of 2, then we would just add 2 more terms using t squared as the added variable, or attach variables to it, and everything else would be the same. Okay, so but for us, this would be the solution for number 3.